All right, are we on? We're on. Good afternoon, Kiev. Come on, people, come on, give me some love. This is my first time, not just in Ukraine or Kiev, this is my first time in Eastern Europe at all. So, come on, guys. All right, thank you very much. Been here for a few days already, been having a blast. You guys are awesome. And the Microsoft folks here, DX Ukraine, really put on a really great show, huh? What do you think? Great show? You like it? Yeah. So, first of all, thank you so much for having me over here at Dev Day Kiev. It's a really exciting day. I'm really happy to be here to talk to you. So, my name is Landry, and I'm a technical evangelist for Microsoft. So, I have colleagues here, of course, in Ukraine, but I'm originally from Canada. So, for those of you that can pick up accents, my accent is actually a French-Canadian accent applied to English, but I now live in New Jersey. Who knows where New Jersey is? All right, a whole bunch of you. It's right next to New York. Anybody ever watched like The Sopranos on HBO? Yeah? So that's where New Jersey is. That's where I live. So, all right. So we're basically halfway between New York and Philadelphia. I'm part of the New York team over there. So my information is all here. My blog is at ageofmobility.com. You can follow me on Twitter at ActiveNick. If I ever do a Twitter map that shows me all my followers, right now I got a lot of people in America. I would love to see a giant pile of followers right here in Ukraine. What do you think? That'd be awesome. Okay. So all the slides that you see here are already on the internet. They're all my slides shared. All the information is at the end. So you can take pictures if you want, but you can focus on taking pictures of me instead of pictures of the slides. What do you think? If you post them on Twitter, make sure to tag me. And my demos are in GitHub. All right, so what are we going to talk about today? We're going to talk about mobile development. Mobile development is hot, right? Everybody's doing mobile development. Everything is going mobile. There's a lot of work in mobile development, whether you're doing contract work or outsourcing work, or if you're building your own apps even. And what we're going to look at is basically how can you deal with the fact that there are 3 platforms out there right now. There's iOS, there's Android, and there's Windows. So who likes to rewrite the same thing 3 times? Anyone? Yeah, I thought so. So what we're going to look at, basically, oh, there you go. Visual Studio is giving me some grief here. Let's minimize this. So what we're going to do is basically look at what can you do to optimize your work so that you don't have to rewrite the same application 3 times. We're going to look at a product called Xamarin, which is a product from a Microsoft partner. And it allows you to basically use C# across the board. And we're going to dive into that. We'll look at iOS and Android, and then we're going to look also at how we can share the UI. There's a ton of content here. I mean, I could talk about this all day. I have talked about this all day before, and I'm just going to try to give you kind of like a gist of things over an hour. So you're not going to be a Xamarin expert like an hour from now, but hopefully you'll know where to go. And my slide deck is full of links, references, online courses, all free stuff that you can go learn on your own afterwards. So just quickly, do I have any iOS developers in the room? Raise your hand. All right, don't be shy, guys. Okay, all right. So a few of you, 4 or 5, it's okay. I know it's a Microsoft event, like, are we supposed to raise our hand? Is that okay? So I'm sure you don't speak with that accent, but it's okay. Any Android developers in the room? Okay, a few more. Okay, any Windows device developers like Windows Phone, Windows Store? A few more. Excellent. I love you guys already. See, this is good. Has anybody ever used Xamarin before? Wow, a whole bunch of you. Any experts on Xamarin in the room? No, because if you were, I'd tell you, like, maybe you should go see something else, you know? So this session is basically for people that have never played with Xamarin. So the few of you that have already looked at it will bear with me. Hopefully you can still learn something along the way. Okay, so let's look at how we build mobile apps. So traditionally, if you want to build a mobile app, there's a few ways to go. To build the iOS application, you're going to use Xcode. That's the IDE that Apple has released on the Mac. So Xcode is kind of like Visual Studio, except it's not as good. And then you've got, that was a joke, by the way, okay? Maybe you're going to have to learn my American/French-Canadian humor, so I'm going to try it. You're going to use a language called Objective-C or Swift. I mean, Apple has released a new language because everybody said that Objective-C was really bad. And then finally Apple said, OK, you're right. And then they released Swift. Then if you want to build the Android app, and I hear Android is quite popular here in Ukraine, right? Who has an Android phone? Yeah, I thought so. OK. So if you want to build an Android app, well, you're going to build it in Java, very popular language. Java is awesome. You're going to use an IDE that's going to be either Eclipse or, thankfully now, we have another option, which is Android Studio, which is much better because Eclipse is, it's painful. And then to build a Windows application, of course, well, that part I assume you guys are familiar with it. You're going to use C# with Visual Studio. So what that means is, 3 different IDEs, 3 different languages, 3 different SDKs to learn. And on top of that, these 2 you can build on a Mac, and these 2 you can build on Windows. So you'll have to actually use 2 different operating systems to do this. That's why I'm here, the Microsoft guy with a Mac in front, because right now I'm running Windows on a Mac, and then here, this is OS X. And this is Windows, and this is OS X. I could do this all day. There you go. OS X, Windows, there you go. All right, so this is all good and fine. If you want to rewrite everything 3 times, go nuts. It'll be great. You'll be wasting a lot of time. But you will be able to build an awesome user experience because your app is going to be finely crafted for the experience that each user is expecting on their platform. Your productivity, though, not so good. You cannot reuse anything. You cannot reuse your design. You cannot reuse your code. None of it. Then a lot of people have looked at this and thought, surely there's a better way of doing this, right? Do we really have to rewrite things 3 times? So that's when you've got all these other tools that came along, these kind of like app generators or these like hybrid approaches, especially stuff like PhoneGap, Cordova, which is not bad, by the way. Cordova is great. Cordova you can actually use in Visual Studio. Cordova says that you can basically use web technologies and create a native wrapper around it. So if you're a web developer and you're using JavaScript, it's all good. You can create, but it's not really going to be a native app. It's going to be what we call a hybrid app because it's web within a native shell. And the problem also is this is what we call the lowest common denominator approach, which means you're not going to be able to use the full features of the native platform. So if there's a specific feature of the platform you want to use, but Cordova doesn't expose it, then you can't use it. Or you're going to have to write your own plugins or find plugins, and then you have to make sure the plugins work with all 3 platforms. So these approaches, I mean, they're good sometimes, and you'll probably find some work also in Cordova. It's quite a popular framework. It's very popular in the enterprise. So if you see companies that are basically building apps for their internal workforce, Cordova is very popular. The problem with Cordova is that you're not going to have as good a user experience because you're not using the native controls of iOS or the native controls of Android or Windows. You're basically using web controls. It's a web UI, it's a web view, and your developer experience is not going to be as good as you might expect. So just curious, any web developers in the room? Surely there's a few of you here. Yeah, okay. Let me ask you a question. Anybody here, whenever you build a web app, can you actually build your web app and publish it, and then it automatically works flawlessly in all the browsers out there without any testing or tuning? Anyone? Yeah, I thought so. Well, if you think it's like that on desktop, it's the exact same thing on mobile. Because when you're using web technologies on mobile, you're actually running it in Internet Explorer or Edge, and in Chrome or the old Android browser, or in Safari or Opera Mobile. So there's browser fragmentation in mobile, just like there's browser fragmentation on the desktop. That's why your developer experience, even though you're writing the app only once and hopefully running it everywhere, in reality, you're going to have to do a lot of testing and tuning and debugging. So it's what I call write once, debug everywhere. That's pretty much how it works. Then there's another option that came called Xamarin. So Xamarin is a third-party product from a company called Xamarin. And what they've said is basically, let's take C# and let's bring C# across the board so that you can use C# on iOS and C# on Android. And C#, well, on Windows, we already have that, of course, because Microsoft already provided it. And then on the server even, you can still use C#, but Xamarin is giving you this piece right here. And you're going to have high performance because it's native API access. And you're going to have full APIs as well in terms of if there's a specific feature of iOS or a specific feature of Android you want to use, it's going to be available for you. Even if that feature, for example, on Android doesn't exist on Windows or iOS. Or, for example, if you want to use some of the speech features from Windows that don't exist on iOS or Android. So it doesn't have to be a feature that exists across the board. So let's look at that, how we can do this. The beauty of this is that because you're building a native application, your user experience is going to be awesome because you'll be able to finally craft a perfect user interface for each platform. Because that's the trick, by the way. You'll notice we have shared C# mobile here. That means this is all the non-UI code that you get to share. The UI, you still have to rewrite 3 times. So it's not completely write once, run everywhere. You're going to be sharing a lot of code, what we call the non-UI code. So that means things like database access or data synchronization or REST calls to the server, authentication, data validation, business rules, object serialization, JSON calls, and stuff like that. Basically, a lot of the code that you would write anyways in all 3 versions, that code you write just once and it's shared. But the UI itself, and especially if you use proper patterns like MVVM, for example, well, MVVM allows you to give a proper separation of concern between your business non-UI code and the UI interface. So since you're only going to be rewriting the UI, you can still achieve anywhere from 70% or 80% of your code that's going to be shared, or sometimes even more. It depends. And there's even a technology that hopefully I'll have time to show you that lets you share the UI as well. But for now, let's start with the approach where we're going to have to rewrite the UI 3 times. So because you're rewriting the UI 3 times, you have a perfect experience for your user. You are using the native controls of that platform. But because you're sharing so much code in the non-UI part, well, then you're going to have pretty good productivity. And productivity is good because that makes you more valuable as a developer. It lets you tackle more projects. And this is where you can, for example, command like a higher rate as a developer because you're so efficient. That's good, right? Higher rates are good, I'm told. So, okay, but how does that work? Because I might say like, wait, let's run C# on iOS. Like, yeah, Apple didn't do that. So how does that work? How do we run Apple? How do we run C# on iOS and Android? Anybody ever heard of Mono? Familiar with Mono? Yeah? Okay, your hands are working well today. That's pretty good as well. I'm happy to see that. Well, so Mono is a framework that was introduced over 11 years ago. And it basically is an open source implementation of .NET that was originally created for Mac OS X and for Linux. And since iOS is a derivative of Mac OS X, and since Android is pretty much mobile Linux, then it was not too far-fetched to take Mono and then bring it to iOS and Android. And that's exactly what Xamarin has done. And by the way, the geniuses that have created Mono are the same geniuses that have started Xamarin. They're the same people. So really smart people that have created this, and that's the tool that we have today. Now, but what does that mean? Like, what code can I share? What code do I have to rewrite? So let's look at .NET. Okay, so if you're writing .NET code today, you're going to have a whole bunch of namespaces called system.something. All those namespaces are pretty much part of Mono as well. So that means you can use numerics and strings and link and XML and a service model and net and data and everything. So this is just a sample. There's like, of course, thousands of those. So all of that code that uses system for anything that's not specific to the platform or anything that's not tied to the UI, that's code you'll be able to share. But then even on Windows, when you build an app for Windows Phone or for Windows Store or Windows 10, you're basically going to end up at some point writing some code that will only work on that one platform. Okay? So that means, for example, right here, we have namespaces. Every time you see a namespace that starts with like Microsoft.something or Windows.something, that is code that is specific to Windows. So every time you use those namespaces in your project, this is code that you will not be able to share on iOS and Android. And when it comes to iOS, it's the exact same thing. Because Mono runs on iOS, then you have all the same namespaces for all your non-UI code you can use. But then, of course, iOS comes with its own SDK, right? You got all these frameworks. That's what they call it, framework. We call them namespaces and assemblies. They call them frameworks. And all these frameworks are basically available to you because what Xamarin does is they're basically exposing the entire iOS SDK as a bunch of wrappers, if you will. It's like just a bunch of p-invoke calls from C# into native code, and that means that all those namespaces, those frameworks like Core Graphics or UI Kit, which is used for Cocoa Touch, the UI on iOS, the Map Kit for Apple Maps, and Core Motion for accelerometers and things like that. So all of these frameworks are now exposed as namespaces on iOS. With Android, it's the same thing. You got your core .NET classes, and then you've got your classes that are specific to the Android SDK that are exposed to C#. So whenever you call code that's going to be specific to a platform, that code cannot be shared. Whenever you call generic .NET code, that code can be shared. And of course, there's a lot of magic that Xamarin is doing, for example. So whenever you use strings, well, there's strings in .NET and Windows, and there's strings in iOS, and there's strings in Android. Well, if you can use the iOS and the Android strings if you want, but it's easier if you just use the .NET strings everywhere. This way, you don't have to write as much code. So this is all good and fine, but you guys want to see it in action? Yeah? OK, let me give you a demo. And I'll try to go as fast as possible on this. So I apologize right now. Visual Studio, this is Visual Studio 2015, but I'm using a resolution that was probably invented in 1993. So the screen is a little cramped right now, so I'll do my best to show you the value of what we have. So you notice here what I have is I have a solution. So first of all, to install Xamarin, there's two options. You can just go to xamarin.com/download, and then there's an installer from there, and you can install it and try it. There's a free trial, and no, it's not free completely. It costs money. I got a slide about cost and everything, but hopefully this is something you'll be able to offload to your employer, your clients, or something like that. Whenever you create your Xamarin project, then you're going to have something like, for example, here I have a solution with 5 different projects in it. I have the Android project, the iOS project, and then I have an older Windows Phone 8 project. I also created a newer version, which is a Windows 10 project here. And then the idea is that I need to have some code that I'm going to share. Some code that I don't want to rewrite multiple times. For the sake of simplicity here, I didn't bring a demo with thousands of lines of code. I just wanted to show you some of the essentials. So this is kind of like Hello World, but Hello World is calling a REST service because there's not a lot of business logic in Hello World, right? So what this does is I have a weather class, and my weather class, can you guys see this? I know. Should I switch to the light theme, maybe? Yeah? All right, let's do this. Let's switch to the light. Because I use the dark theme because apparently you're cooler if you use a dark theme. So that's what I wanted to do. So, and since I'm a nerd, any chance I have of being cooler is good. All right, is this better? All right, cool. See, not as cool immediately. You can look at it, you go, huh. Anyway. So what I have here is a data class, and it's just a weather class. So this is used to, the service I'm going to call is a weather API. It's called openweathermap.org, and they have a free tier you can use, and I'm calling weather data. And then it's going to return data, weather data to me in a form of coordinates, a list of weather objects, some strings, main weather, clouds, and then in my main weather, I'm going to see things like the temperature, the min, the max. It's kind of weird. Sometimes they return the same value. It's not my code. It's their end. That's the problem. No, I'm not kidding. And then the idea is that I have this code here. So let's imagine that this code right here, and no pictures of my key here, okay? This is my private key, okay? I'll change it afterwards anyways. You can request a free key anyways. You just go to the URL, openweathermap.org, and you can request a free key. So imagine that this is thousands of lines of code that you don't want to rewrite again. So what this does is basically, it's an asynchronous task. So right away, all of this here is going to be shared code. code that's going to run on iOS, code that's going to run on Android and on Windows. First of all, right here, async task, you can actually use the asynchronous framework with Xamarin. So that's awesome, because of course, any mobile app needs to be non-blocking. The last thing that a user wants on their phone or their tablet is to push a button and then to see like an hourglass pop and waiting, spinning, and the whole thing is frozen. Okay, this is not Windows circa 1995. Okay, this is like an iPad, or this is an Android tablet, or a new Windows tablet. So nothing can block. So it's an asynchronous call that returns a weather route object. And then I receive a location. And then what I do here is I create a new HTTP client. I format my URL with a location in there. I make a call to get the string asynchronously, and I await that call. I'm going to get JSON data back. And then using JSON.NET, you guys use JSON.NET, I hope. Yeah? If you don't, then you need to be a better developer and use JSON.NET. It's free and it's super easy. With one line of code, I can deserialize my data. Let me move it up so it's not on the screen edge. With one line of code, I deserialize my JSON data into my weather route object, and now I have a full data structure of weather data. So that's the code that I don't want to reuse. I don't want to rewrite many times. Now, the key is that let's look at the Windows version first. That's the easy one, right? So I got a nice Windows 10 version here. Let's set it up as a startup project. Okay, and then what I'm going to do here is say, okay, x86. Now, the thing is, I'm missing a lot of buttons here. There we go. All my toolbars are all like compressed. So I'm going to run this on a local machine so you can see what the code looks like. It's not the most impressive code around. It's a very simple UI with, with a text box asking for a city, and then it's going to return weather data to me. Okay. I don't need Azure here, so that's fine. We can unpin this. That's good. There's my UI right here. It thought it was on a different screen. So this is a Windows Store app, a Windows 10 app, basically. As you can see, it's fully resizable. It could be running in a window, because this is Windows 10. It's not Windows 8 anymore, where everything is full screen. And then, let's see, can I? All right. I'm going to enter the name of a city, like, I don't know, Kiev. Like this. I call get weather, and then I get the weather data. I told you it's kind of weird. They return the same low and high and everything. Again, some days it works, other days it doesn't. It's their API that's going to screw it up. I think it's because I'm not paying for it, so they're not sending me good data. You get what you pay for in life. So I got weather data here, very simple. So that's I assume you guys know how to build this, right? This is XAML, C#. If I look at the code behind this is like super simple, so let me stop it. So let's just take a look at the code behind the form, behind the page here, okay? If I look down here, I initialize a new open weather map, declare an open weather map service object, I create a new one, and then here this code is pretty much, in my button click, it's asynchronous. I take the location from the text box, I put it in a string, and then I call open weather map service, get weather location, and then if my results are not null, then I format the message that says the current temperature in is 0, 1, 2, 3, and then I simply do a string format too. So it's not like rocket science code. But the idea is that now we want to write an iOS version and an Android version of this. So let's look at the Android version first, right? A lot of hands went up when I said Android, so let's look at Android first. So what we're going to do now is, again, just to recap, one thing I didn't mention is, remember when I said that, I move my mouse, remember when I said that I had 4 projects? So these are different clients, Windows Phone 8, Android, iOS, Windows 10 client. And then this is the shared code. The shared code, the shared project, is basically, it means that all the code that I put in this shared project is automatically going to be used whenever I build any of the other versions. So that means whenever I build the Windows 10 version, it's going to take all the files in the Windows 10 version plus all the files in a shared project and create one build. And when I do the iOS version, it's going to take all the files in the iOS project plus all the files in a shared project and do one build. So a shared project doesn't have a build target. The shared project doesn't generate a DLL or an executable. It's just a bunch of files for file linking. You know, we had a way of doing this before. It was called file linking. You know when you do add existing file, let's say you have a class somewhere in your drive, and you say, I want to reuse that class in my project. And then you say add existing item, and you go find the class, and you click add. What does it do? Really? Okay, it creates a copy, right? It doesn't, I guess I'm going to have to give you all the answers. Okay, it creates a copy. It doesn't link directly to the file there. It takes the file, it copies it to your new project, and then it adds it to your current project. But on the add button, there's a little arrow where there's an add as link. Add as link says, leave the file where it is. I'm just going to link to it. So now you can technically have two projects linking to the same file. Shared projects is just a better way of doing file linking. This is something that we introduced last year with Windows Universal Apps, with Windows 8.1, and we can still use it to this day, and Xamarin took the concept and added it to their projects. Okay, cool. So now let's look at the Android project. Now, my UI, if I look at my Windows 10 project, I'm going to find some of the stuff that I would normally expect, like a XAML page. You guys know XAML, right? So like a XAML page, and then I've got my code behind I showed you, and then I've got the application class right here. But then if I look at the Android project, I don't see the same stuff I'm used to see. I don't see XAML in here. I see something called the main activity. So there's an activity. So all the Android developers in the room are going like, I know what an activity is. Normally you write it in Java, but now you get to write your activity in C#. That's what's cool. So when you open the activity, if we look at the code inside of the activity, first of all, look how cool this is. Look at these using statements here. This is basically creating namespaces for all of the Android classes that come from the Android SDK. And you can use them directly in your code right here. And then in here, we have a class called main activity that derives from activity right here. And I have an activity label on it, which is an attribute that tells me like the name of the label in the shell. That main launcher means this is the first activity. So whenever I launch the application, that's the one that's going to run. Because everything in Android is built in the form of activities. Usually every screen is going to have its own activity. You can also have services that's more like a background service. And then the icon, for example, that's going to be used in the shell. Then look at the code here, same thing. Open weather map service, there you go, on create. So the lifecycle events are not exactly the same because we're not using the lifecycle events from Windows, it was using the lifecycle events from Android. So right here, I create my new open weather map service, but then the thing is there's a big difference between Windows and Android. Because in Windows, when you have like a XAML page, the XAML page is actually a class, right? We declare a class in the syntax at the top. And then when we create the code behind, what kind of class are we creating? We're creating a partial class. Because partial classes allow you to have two different class structures that once merged together form one class. So what that means is the class has both like some XAML content and also some C# content. And in the C# content, what happens is then you can automatically start referencing everything that's inside of your XAML document. So you could go put a text box, a button, a label, whatever in XAML, and then directly in your code behind, you can start referencing it right away because the partial class knows about the other side of itself, which is the XAML code. Android doesn't work like that because Android has the activity code and the UI code, which we haven't seen yet, and they're completely decoupled. So that means in your activity, you cannot start referencing controls by their names and say, hey, text box this and button that. You first have to say to the activity where its own UI is. So we use something called set content view. And then we say the view associated with this activity is in resource.layout.main. All right, let's see where that is. So we go to resource.layout, and then I see this thing here called main.axml. And when I open AXML, now the Android developers in the room are like, I know what an XML layout is, but I don't know what an AXML is. So it's the exact same thing, except that Xamarin renamed the extension to AXML because in Visual Studio, when you double-click on an XML file, it opens up the XML editor. Whereas when you double-click on an AXML file, you get an Android designer. That's the only thing. In fact, if you already have some native Android projects that you've built in Eclipse with Android or Android Studio using Java, you can take your layouts in XML and you can bring them right over to Xamarin and they will work. Because these layouts they're a little bit like XAML when you look at it, because you've got a control here, a page here, and when you look at the toolbox, what you see in the toolbox, you see a whole bunch of things that they don't look like Microsoft things. They're basically grid view and scroll view and web view and tab widget. And basically you have all the widgets from the Android UI that appear here. And when you create your UI, you go to source, and then behind, you find a UI that's essentially built in XML. Just like XAML is also built with XML, but the schema is not the same. Android, they have their own XML schema for their layouts. XAML has its own schema for its layouts. But any XAML developer that looks at this, immediately you're going to recognize, yeah, this is a linear layout, and I've got an edit text, that's a fancy name for a text box, a button, and a text view, which is a label. And then these are included inside of the linear layout. So the linear layout is kind of like a stack panel. So you build your UI in XML this way. And then you notice how you have these IDs here, like text location and then my button. Well, the thing is, back inside of your activity, before you can use any element, before you can start accessing the properties of a control, or before you can start like attaching an event handler, because you probably, I don't know if you noticed, but in the XML code, there was no event handler in there. There was nowhere that it say like click, when you click it, launch that handler. That doesn't exist, because the XML layout doesn't know anything about the activity behind it. It's not like XAML. So here, we first have to say, hey, before I can use a button or a text box or a label, I have to go find it. So once I've loaded my content view, then I say, find the view by ID, and go find the one that has an ID called text location, and return that as an edit text. And then same thing, find the one called label message, and return that as a text view. Once I have those, then I can start using them in my activity. Same thing with the button here. I go find, in my view, go find the button that has the ID called my button, return that as a button, and then attach a handler to it. So here we're just attaching a Lambda directly. We could attach a proper event handler if we wanted. Okay, but notice see how cool this keyword is? Async framework. You can use it. Even though we're inside of an Android activity written in C#, you can use the same asynchronous framework and task parallel library from .NET inside of your iOS and Android projects. And then that code here, well, we've already seen it, right? It's pretty much the same code we had in the button of the XAML page. So we get the text, we call getWeather, we await the call, and we format a string, and we display it on screen. Ta-da. So let's run this. So to run this, what I'm going to do is I'm going to use an emulator here. Let me just launch it first, because that can take, depending on the machine you're running. And right now, I'm also running virtualized, because Windows is virtualized inside of OS X. So I'm going to launch my emulator. And the emulator I'm going to use, which is way too big right now, the emulator I'm going to use is actually the Microsoft emulator for Android. It's basically the Visual Studio emulator for Android. So yes, Microsoft made an Android emulator. We basically took the same emulator technology we were using for Windows Phone and Windows 10 Mobile, and we created an Android version of it. Because, I don't know if you've heard, but Android emulators from Google, they're a tad slow. And when I say slow, I mean really slow. Any Android developer in the room is going, yep, it's very slow. So I don't know if you get the meaning, but it's what we call in English continental drift slow. You know, it's basically, it moves at the speed of continents, so, which takes millions of years. So, and it's not because Google has bad developers, it's because their emulator is pure software. It doesn't use any virtualization technology, it doesn't use any hardware acceleration, that's why it's very slow. Now here, this one still appears to be a little slow, that's because I'm running a VM within a VM, and OpenGL error has occurred. Great. Okay, so everything was working fine this morning, and I have a backup for this. So, let me see. I have an Android phone here that I can use. Let me just launch it. I should have launched it before. Okay, I don't know why it's doing this. It might be because of the size of the screen, because the emulator requires a screen resolution from at least 2008 and above. All right, so let me see if I can launch it manually first. So let's go to VS Emulator for Android. Hopefully we can run this. Okay, so let's try this again. See, I can't even see all the buttons on this. This is kind of painful because I cannot move the screen to make it. So can I right-click on it? Actually, yeah, I can double-click on it and launch it. Let's see if it works. If it doesn't, I'll use my phone here as a backup. If not, I have some slides to show you what it's supposed to look like. It's like anything in life, you know. Everything was working just fine earlier in the speaker room, and then next thing you know, stuff doesn't work here. Okay, so while this is starting again, let me see if I can resize this to make it a little smaller. There you go. Hopefully that's going to help something. Let me in the meantime, I'm going to connect this to Wi-Fi. Oh, great, Wi-Fi, I just remembered. I don't know if I have to be on the same network. And the way that the Wi-Fi today has been working, I don't know. So who's been having perfect Wi-Fi all day? Not me. Anyway, if it doesn't work, I can always use, let's plug this here for now. Anyway, one more shot, and then if that doesn't work, we'll have to try to launch something else. So OS is starting. Oh, there we go. Android is loading now. Better luck. Yes. Cool. All right. Maybe that was before because it was using the whole screen. So let's minimize this. Let's go back to Visual Studio, and now let's say run this on this emulator, which is already running. So hopefully that's going to go a little faster this time because the emulator is already running. Okay, it's going to run it. There you go. Okay, so now it's using a dark screen. I'm sorry, I have no way of really changing it easily. So now I can call my code here, and let's look for London, UK here, and let's call get weather. And then temperature is 58 in London. Okay, so now, again, C# program, we use the same weather routine that was shared, and now it's running on Android. All right, I have to accelerate the pace here because I still haven't shown you iOS and I have a lot more stuff to show you. So let's stop this right now. Where is my stop button in Visual Studio? Tools, debug, stop debugging. There we go. Okay, so that was the Android version. For the iOS version, this one is going to be a little trickier because I'm supposed to see something on the toolbar here. Oh, there we go. Am I connected? Yeah, connection status looks good. So I need to have this little green checkbox here. This is telling me that right now Visual Studio is connected to the Xamarin build host. Where is the Xamarin iOS build host? It's right here. It's on the Mac side. Because yes, even though you are using C# in Visual Studio to build an iOS application, you still need a Mac. I know, it sucks. So that's how Apple makes money. You know, they sell machines. So, and it's not, there's nothing you can do about it. You need a Mac. You don't have to buy a super crazy expensive Mac, even though every Mac is always expensive. It's true. I mean, if the machine costs you 500, it should have cost you 300. If it costs you 1,500, it should have cost you 800. You know, that's how they make money. So this is OS X right here, and what I'm doing is I'm running a program called the Xamarin iOS Build Host. This is basically a listener, and it listens for calls coming from Visual Studio using the remote debugger on Windows. And then it sends the commands over to Xcode, which is the IDE from Apple. So you need to install Xcode on the Mac. You need to install Xamarin on the Mac. Here, because I'm traveling and because networks are what they are, I run everything on the same box, so it's easier. But at work or at home, what you would need to do is either have, like me, an overpriced Mac, or you can have like a regular Windows machine with another Mac, like it could be a MacBook Air or a Mac Mini that's like $500 or something, which I know is pretty expensive even. And then you just run the build host on the Mac. You cannot share Macs between developers, so you cannot have like 10 Windows developers with one Mac in the middle. Well, you could, but you notice how I'm currently paired with Visual Studio. So the Xamarin Build Host can only be paired with one instance of Visual Studio at a time. So even on this machine here, if I launch a second instance of Visual Studio, only one of them can be connected to the Xamarin Build Host. It's kind of annoying, I know, but Apple made it this way. They made it so that it's both a legal and a technical requirement that every single iOS application be built using Apple tools, running on Apple's Mac OS X, running on Apple's Mac hardware. It's a closed ecosystem. So this green checkbox here tells me we're green, we're good, we are currently connected to the Mac side of things. So now, if I look at the Mac side of things here, very quickly, I have, so let's go to iOS, set as start a project, there we go. Then in here I have, again, a bunch of different things. I don't have layouts, I don't have XAML, I don't have activities, but I do have a view controller because Apple has decided that you have to use MVC. Whether you like it or not, you have to use MVC. Because you know, Apple always knows better than everybody else. So they decided for you. And then for the UI, I can open the Storyboard Designer here, and that one will be a little slow. Because when I open the Storyboard Designer, it actually needs to have a conversation with the Mac side of things for Xcode to even be able to show a designer here. So you need that connection. We have no choice. So that's why the designer can be a little sluggish. But the view controller, of course, can be automatically tied to the designer. So if you've ever done iOS where you have to use outlets and actions and wire them together, and it's annoying, right? It's really a pain. You don't have to do that. Thankfully, with Xamarin, you can just double-click on a button in a designer, and it creates an event handler for you in the view controller. Thank you, Xamarin, because Apple didn't get it. And if I look at my view controller here, while the Storyboard Designer is still loading, what I have here is same thing. I've got monotouch stuff. So monotouch is basically the old name for Xamarin iOS, so you'll still see these things. And then here, you've got a whole bunch of weird life cycle events. These are the life cycle events from iOS. Things like did receive memory warning, and view did load, and view will appear, and view did appear, and view will disappear, and view did disappear. You think I'm joking, but this is actual iOS code, okay? This is not Xamarin stuff. This is Apple iOS stuff. That's how they name their lifecycle events. It's like kindergarten for developers, except with a really bad language. Anyways. And now here we have get weather touch up inside. So it's not a click. Get weather is basically a button right here, button get weather. And the event handler is not a click. Normally it would be click, right? On a button, click handler. Now it's called a touch up inside. I know it sounds dirty, but so touch up inside. Get your minds out of the gutter. It's actually, because you know when you're on a tablet or a phone and you tap on a button and then you go, oh, I didn't want to press that. What do? You slide your finger off and you let go. You just did a touch-up outside. The touch-up is not inside the button, the touch-up is outside the button. So now you have to say what happens when you do a touch-up inside. You'll never forget this. There is an event handler for touch-up outside too. So if you really want to mess with your users, just go put some code in there. But don't expect great reviews in the store. And now the code that you see here, it's the same thing, right? We're basically getting the location, we're calling getWeather, and then we're formatting a string for the results. So do I have a designer yet? Yes, I have a designer. So I have my designer here. Let's fit it, the whole thing on screen. So this is the UI, the edit box. This is the label for the button. This is the label for the data. And then what I'm going to do is I'm just going to run this. I'm going to close this for now so you can see it. So I'm going to say I want to run this on the iPhone simulator. Remember that to run this, it's going to be run and compiled by Xcode, which means the code is going to run on the Mac. So if you have your Windows machine and your Mac as separate machines, make sure that it's not on the other side of the office, because you'll have to go there to debug it. Okay, because the simulator is going to run on the Mac, and so let me run it here. I'm going to run this here. The simulator is going to run on a Mac, and if you debug on a physical device like an iPad or an iPhone, that has to be connected to the Mac as well. Okay, so make sure it's within reach, especially if you're doing breakpoint debugging, which you can. Hit the breakpoint. No. You go back, hit the next breakpoint, go back and run. Yeah, it's good because it keeps the developer in shape, you know, but not super productive development. So now in this window here that is way too big, let's scale it a bit to like, I don't know, 50% like this. And then let's look for the weather in Paris, France. Get weather. There you go. So same weather code that's been running on 3 platforms. And even though some of the code we had to rewrite 3 times, like the UI, we did write it all in C#. We didn't write it in Java. We didn't use this ugly Objective-C thing. So it's all good. So what do you think, right? 3, all worked? Good? I get nothing, really? Okay, thank you. Man, tough crowd. Okay, so in the brief time that I have left, I was hoping to show you kind of like the shared UI code, but you know what? I'll hopefully be able to show you on some slides. But let me give you a little bit of info, because normally this is a session that takes me at least 75 minutes to run. I only have 60 here. So let me blast through this quickly. So first of all, why is Xamarin good? Aside from the fact that you write things in C#, well, you use the native UI. You saw like how on the Android designer, it was the Android widgets that were there. Not Windows widgets, not web widgets. It was the Android widgets. Same thing with iOS, and with Windows, of course, it's XAML. High fidelity API access, because that means that you get access to all of the APIs of the platform. So in the piece that is not shared, you can actually call all of those custom APIs if you want to have them. And the performance, we'll get to that in a second. Couple of very important statements to remember about Xamarin is that, first of all, 100% of the native APIs of iOS and Android and Windows, of course, are exposed to Xamarin apps. Which means, and this is really important, anything that you can do in Objective-C or Swift or Java, you can do in C# with Xamarin in Visual Studio. So when sometimes people ask like, yeah, I heard about Xamarin, but can you do this? And is this feature supported in there? The answer is always yes. If you can do it in Objective-C or Swift, you can do it in C#. Same thing with Java. Now, in terms of the performance, the way it works is that if we look at Android, it's a very similar model to .NET, right? Because Android is a managed language. As a managed language, it means it has a runtime. The runtime is called a Java virtual machine. The virtual machine on Android is called Dalvik. So there's a new one called Art, which is the Android runtime. They're both supported. And what happens is that normally, whenever you compile a Java application, the Java app gets compiled into Java bytecode, and then at runtime, the Dalvik VM JIT compiles the bytecode into native machine code for the device. That's how Java runs on multiple platforms. Well, here's the same thing. Instead of using the Dalvik VM, we're using the mono runtime. So the C# code gets compiled into IL code, and then the IL code at runtime gets JIT compiled by the mono runtime into native machine code on Android. So it's not an extra layer on top of the Dalvik VM, it's instead of the Dalvik VM, so you get the same performance. With iOS, it's a little trickier because iOS is an unmanaged environment, meaning that all the code is native machine code, there is no intermediate language, there's no managed code, there's no runtime. So what Xamarin has to do is to use a technique called ahead-of-time compilation, where they basically take all the code and they go into one shot from C# to IL and then JIT compile it right away to machine code for iOS. Kind of like NGen, you know, when you pre-JIT your .NET assemblies, or now with Windows 10, we have .NET Native where everything is compiled for you as well. So the performance is really good. The performance is pretty much equivalent, to be honest with you. You might have a little bit of bloat because, especially on the iOS side, it has to add a few more of the mono runtime classes to your assembly. So your application size might go up a little bit on iOS. But it's not something that anybody's ever complained about. Every time there's a new feature coming out on iOS and Android, Xamarin adds it. In fact, on iOS, since iOS 5, they've been able to release same day. The same day that the iOS version goes live, because they were in the beta, not because they code very fast, they can actually release a new version of Xamarin the same day to support the new features of iOS. On Android, they support all the other weird versions or variants of Android, like Amazon Fire or Android Wear watches, or the now defunct Google Glass. So that was money well spent. So if we look at the cost, okay, there's a cost, all right? It's not a free product. There is a free version, but the free version is kind of limited. They only let you build like a certain size of app, and after that, they force you to go to the Indie edition. In a nutshell, I'm sorry, I only know the American dollar prices. You'll have to call them to see if they have specials for Ukrainian currency. And I'm not even going to try to pronounce your currency because I've tried and I butcher it every time. So it's $300 a year per platform. So basically that means for a developer doing both iOS and Android, it's going to be $600 a year, US, for the Indie edition, and $2,000 for the professional edition. So yes, it's not cheap. But if you have customers, very often they might have their own licenses. I highly recommend that you learn Xamarin because it's a skill set that's in really hot demand right now. And the cool thing is that it's a skill set that it's not a race to the bottom, you know, to be the cheapest developer around. It's actually a skill set where you can actually command some very high rates with that. So you can make up that money pretty fast, especially when it's an organization paying the bill for it. You can do this either in Visual Studio or in Xamarin Studio, which is their own IDE. So if you use the free edition, you're going to be using either Xamarin Studio, or the free edition now comes prepackaged with Visual Studio 2015, which is free. Of course, you can use Visual Studio 2015 Community Edition, and in the custom installer, you can install Xamarin from there. So Xamarin Studio, I'm not going to go there. To share UI code, I don't know if I'll have time to show it, but there's a technology called Xamarin Forms. And what it lets you do is basically to create the UI just once, and then it will automatically adapt that UI to the native platform. That adaptation is actually done at runtime. So that's why the performance, you're going to get a little bit of a performance hit when you're using Xamarin Forms. This is kind of Xamarin's answer to Cordova. So whereas the traditional classic Xamarin approach, which is the one I've been talking about for an hour, said you share non-UI code and you rewrite the UI 3 times. With Xamarin Forms, you can actually even share the UI code, but you do have the option of customizing the UI a little bit if you want. And this is where I would need another 20 minutes to show you all this. So what you get over 40 pages, layouts and controls, two-way data binding, there's a navigation controller, there's an animation API, there's a dependency service you can use to call into specific classes under the hood, and a messaging setter. So what it means is that, let's say that you're creating, I don't know, like a login screen like this. Well, you have XAML code right here, and that XAML code you write just once. So you actually use XAML to create it, but there's no designer. So there's no like visual designer that shows you what it looks like. You have to use your imagination to look at this, and then afterwards, when you run it, it will actually create a native interpretation of the UI using the actual native controls of the platform. Okay? So it's not going to give you a web widget or a Xamarin widget. It's going to give you an actual Windows text box or iOS UI something, I forget, entry, I think, or an edit text from Android. So that means, for example, if you have a Xamarin button, it becomes an Android button with a clicked event, an iOS button with that touch-up inside event there, or a Windows button with the click event right there. And then you get a whole lot of different pages you can use, like a content page, a master detail page, navigation page, a tab page. Like for example, the tab page, the tabs are going to show up at the bottom on iOS, but on Android, the tabs show up at the top. And on Windows, well, there's no tab control on Windows Store or Windows Phone, so it uses a pivot instead, which is kind of the same concept as tabs. And then you got different layouts to kind of move your stuff around, because of course the screen resolution is going to change from one device to another. And you've got absolute layout, relative layout, grid layout, scroll view, and then the controls, you basically get to use the bread and butter controls that you find on every platform, like a date picker, a button, a label, a list view, a map. The map, for example, is either going to be a Bing map or an Apple map or a Google map, depending on the platform. And yeah, so this is where I was hoping to show you a quick demo of this. What I'm going to do is I'm going to finish my slides, and hopefully I can show you what the thing was supposed to look like. I had a separate deck with screenshots. So to share code, you can either use the shared project, or you can use, well, NuGet packages, of course, if you have your own or if you're using somebody else's code, or you can use portable class libraries. So portable class libraries is basically a DLL, a .NET DLL that is meant to run on multiple versions of .NET. So if you put your code in there, the code can then be shared across iOS, Android, Windows. You can even use it with like WPF and Windows Store and Windows Phone and things like that. So I'm sorry I'm going a little fast here, but I only have 2 minutes. So, okay, so in the end, what I want you to remember is whenever you try to decide what approach to take to build a mobile project, you either you can use the platform tools from the native platform like iOS, Android, and they're free. That's great. These tools don't cost anything. And you'll find a lot of documentation, a lot of articles on Stack Overflow, a lot of videos and everything. But you will have to rewrite everything 3 times. Whereas if you use Xamarin, well, with Xamarin, there is a cost associated with the tool, but you, of course, don't have to rewrite everything 3 times. But of course, you're going to have a dependency with a vendor now. You're not going to have as many third-party libraries and controls available, although there's a lot of control vendors like, like Telerik and Infragistics and Syncfusion and DevExpress. They all make controls for Xamarin now. But the extra cost is definitely the only downside. But usually, from a productivity point of view, for whoever pays for the project, it's going to be cheaper to use Xamarin than to use anything else. But what I just want to leave you with is whenever you decide on building a mobile project, don't always use the same technology for everything. Sometimes Cordova is going to be the better answer. Sometimes Xamarin is the better answer. It depends who you're building it for, what's the skill set of the team. Is it a .NET team or a web team? What's the time frame that you have? Do you have months and months to build multiple versions, or do you just have 6 weeks to build 3 versions? So there's a lot of questions to ask. So in retrospect, there's no silver bullet. Xamarin is definitely an awesome approach to share code, but always ask yourself, what are the project considerations where you might use something else like Cordova instead? So you can do all of this in C#. You don't have to learn Java or Objective-C or Swift. And you've got access to all of the native features of the platform. You also get access to shared UI code with Xamarin Forms. And to take it from here, so I've got a whole bunch of demos online that you can go download from there, like including the My Weather demo is the one that uses Xamarin Forms. There's a buddy of mine at Xamarin, James Montemagno, that has some good samples on his GitHub as well. So you can get a lot of code there. On Channel 9, Microsoft Channel 9, we have a lot of videos on Xamarin as well. So if you just go to Channel 9, search for Xamarin, you'll find a whole bunch of videos there. Xamarin themselves, they have their own conference with a lot of video content, all downloadable for free, or you can stream for free. So it's great. And I know I'm going fast here, but the deck is already online. The last slide is the one you need to take a picture of, because that's the link to this deck. They have a university where you can get training. They have their own certification program, so you can become Xamarin certified as well. And then you're probably familiar with MVA, right? Microsoft Virtual Academy. If you're not, it's all free. It's all free training. So if you like online training, that's all free. It's there. And there is actually a full one-day class, completely free on Xamarin on Virtual Academy. So that means you can go learn this yourself right now. Just go to ak.ms/MVA Xamarin. That takes you to Virtual Academy. This is my own course that I've recorded on the Virtual Academy. It's not Xamarin, it's about speech and Cortana. It's really cool stuff. So this is just a shameless plug for what I've recorded. And there's books available. Pact Publishing has a lot of good Xamarin books. That's the slide you want. All right? So, yeah, this is actually my license plate. It was not taken for some reason. So SlideShare, slideshare.net/ActiveNick. This is my SlideShare where all my slides are there. The last 2 decks that I've uploaded last night are the one from this session and the one that I'm going to do at 6 as well. I'm doing another talk afterwards where I'm going to talk about the server side of things with the cloud on how to build a cloud backend for your iOS, Android, and your Windows application. So I know I went really fast on a lot of things. It's a giant topic that we could literally take weeks or months to talk about it. It's an exciting product. It's very mature by now. And it definitely is the best way to create cross-platform applications so you can share code across the board using the best language in the world, which is C#. So thank you very much, folks. So I'm going to make way for the next speaker, and then come see me at 6 in a different room on Azure Mobile. Thank you.